that I think they will appreciate it. If you don't understand anything because my English is pretty bad, just stop me and I will answer you in Spanish. No, it's okay. English is fine. So today we are gonna talk about how we do continuous integration and continuous delivery with Kubernetes. I don't really know how to pronounce Kubernetes in English. I'm doing my best. Helm and Wercker, which are these three icons that we have over there. So about myself, my name is Javier Cuevas. You can follow me on Twitter on Javier_dev. I used to split my life between two companies, Diacode, which was a Ruby on Rails shop. We were also doing Elixir. I stopped, we closed Diacode a few months ago, temporarily. Right now, I'm focused on Gudog, which is the company or the project we are gonna talk about today, which is basically Airbnb for dogs. It's a marketplace that connects dog owners with dog sitters. In Gudog, I'm the CTO, and now I'm working there full-time. So first thing first, my review of the new MacBook Pro with Touch Bar, which is the one that I was trying to use, and I couldn't because it doesn't work. This is my review, okay? So I just saved you $2,000. A couple of disclaimers. I learned Docker while I was learning Kubernetes in the same fashion that I learned Ruby while I was trying to learn Rails. I always learn everything backwards. I don't know why, so I'm no expert. And also, Gudog is not at unicorn scale so far. We are just at dog scale, but we are planning to get to unicorns at some point. The reason of this talk is just this thing. One day I was, trying to get this thing together, Kubernetes, Wercker, and Helm, and Alex say, hey, why you don't give a tag? And, why not? So here I am. Okay, let's get started. So to tell you the story, I want to start taking a look back to how we did DevOps, or how I did DevOps in Gudog. So our company is 4 years old. We started in the most simple way possible, which is basically we were using a hosting provider, which was DigitalOcean at the time, and the way we were provisioning everything we need, like I don't know if I mentioned it, but Gudog is a Ruby on Rails application. It's a fucking monolith, the ones that DHH likes. So we need things like Ruby, ImageMagick, the database, and everything. So the way we were installing that, it was just by doing SSH into the server and installing everything. We also set up a Jenkins server to run our test suite. And the way we were doing deployments, it was with a library that is called Capistrano, which is a Ruby library that maybe some of you are familiar with. Next year, we moved into Amazon Web Service. We were just using EC2, which is just the virtual machine from Amazon Web Services. The way we were provisioning the machines was by using Ruber, which is kind of a library slash plugin of Capistrano. It's a Ruby library that allows you to not only deploy the application, but also to provision your different VM instances. For continuous integration, I didn't like Jenkins because the design was really awful. Now it's better, but that version it was really awful. You had these icons with the weather. Who cares about the weather? So we moved to Cpable, which was very fast and it was free. And I didn't have to take care of it. So it was free, I didn't have to take care of it. It was a good deal. For deployments, we were still using Capistrano, but instead of launching the deploys from my machine or someone in the team, the Capistrano recipe was being executed by the Cpable server. Next year, we moved, we were still on Amazon Web Services, but we moved to a service that is called OpsWork, that maybe, again, some of you are familiar with. OpsWork is a service that allows you to provision and deploy application in an automated way, and it's based on Chef. So Chef, again, is a Ruby-based library that allows you to provision things, but OpsWork gives you a lot of the work done for you. You don't have to install the master of Chef. You just need to take care of the receipts that you want to set up, and that's it. We were still using Cpable for continuous integration, and for deployments, we were using OpsWorks. And finally, this year, we moved to Google Container Engine, which is one of the services of the Google Cloud. For provisioning, we were using Kubernetes. For continuous integration, we are using Wercker. And for deployments, we are using Kubernetes and Helm. So this is the approach that I'm going to talk about today. Before we get into that, how many of you have used Kubernetes before? Like half. Okay, cool. So why we choose Google Cloud? Well, I could give you like a lot of different bullshit reasons, but the main reason was that on Amazon Web Services we had credits because we were part of an Amazon program for startups. We ran out of credits on Amazon Web Services, so we had to start. We start to pay for it, and then we managed to get into the same program for Google Cloud. So we had like $15,000 in Amazon, and then we got another 15,000 or I don't know how much in Google Cloud. Also, because Google Cloud right now, because they are trying to compete very hard with Amazon, it's cheaper than Amazon Web Services. Now we are already paying for it because our credits they have expired. And also because it has the best integration possible with Kubernetes. Now, why we choose Kubernetes? Well, to be honest, it was just because a guy from Google told us so. So when you got into this program for startups in Google Cloud, in addition to the credits that you receive, you also get the chance to schedule calls with engineers from Google, and you basically tell them what's your architecture and what are your needs, and they will basically try to either help you or sell you something. So this guy said, no, you have to do this thing with Docker because Docker is the future, and the future in Docker is Kubernetes. And I was like, okay, I can try that. And I had no idea we had no idea of what Docker was, so we really wanted to learn a little bit more, and we give it a try. I have to say that it took me like 6 months to actually manage to run the whole stack of Gudog with Kubernetes, because a few months, Kubernetes is evolving like super fast, and a few months ago it has like a lot of stupid limitations. Like for instance, if you wanted to have a load balancer with HTTPS, with SSL, right, you couldn't get the real IP of the user. I was like, I told the guy from Google, and he was like, yeah, we know this thing. I was like, how do you expect people to run applications in production if you are telling them that either they have SSL or they have the IP of the user? So until they fix a bunch of things like those, we could not move the production environment to Kubernetes. And why we choose Docker? Well, because cPable, it started to get it very slow, and I found Wercker, it was also free. It has like a free plan that allows you to have a private repo, and it seems to be faster. And the UX of Wercker, I have to say, it's pretty amazing. It's pretty beautiful, and in my opinion, it's better than cPable. So now, quick introduction, 3 minutes to Kubernetes for those of you who didn't have the chance of trying it. So what is Kubernetes? Kubernetes is an open source system for container orchestration and more. How many of you have used Docker before Kubernetes? Okay, so most of you, right. So Kubernetes allows you to do orchestration. It allows you to do more things like taking care of the persistent storage and other stuff. It works with many cloud providers, Google Cloud, Amazon Web Services, and so on, and also your own bare metal if you want to. It's open source, and there are, Google is doing an amazing effort to push this thing in a good way, not the way that they did with Google Plus and Google Wave and many other things. And that's it. So basic ideas of Kubernetes that you have to be familiar with. First one is, what is a node? So a node is a VM or a bare metal machine which is running Kubernetes. Pretty simple. A cluster is just a bunch of nodes. So you can have a bunch of VMs all connected, or a bunch of bare metal machines all connected. The idea of Kubernetes is that if you have a bunch of nodes, you treat them like, for you that should be as invisible as possible. Like you treat them as if they were a single unit of computing. Then you have a pod. A pod is just a group of one or more containers. They normally are containers with the same image, the same Docker image, but they could be different as well. And a deployment is, it just defines how many replicas of a pod do you want and how you want to perform with these. So let's say that you have a pod with an image of your application and you just release a new version of your image. So in the deployment, you tell Kubernetes if you want Kubernetes to first kill the existing pod and then launch a new one, or you want to wait until the new one is ready and then kill the other one. Those kind of strategies for deployments, that's what you define in the deployment. And finally, as a service is just, well, that's a typo. This is not a group of one of my containers, just copy and paste. A service is basically a resource that lets you expose one pod in one port, basically, to the either to the other pods or to the external wall. Sorry about that. If you want to learn more about Kubernetes, I recommend the talk from Alex that you did in Code Motion, right? And the videos on YouTube. I think it's pretty great. I watched it. So spend some time taking a look to it. I'm going to wait until you take the picture, right? By the way, my slides were much more beautiful, but he doesn't have the fonts I'm using, so this is just the default fonts. I'm sorry about that. I'm suffering when I'm seeing it. I will upload the right slides later. So how do we use Kubernetes in Gudog? So first we have the internet, right? Because this is what everything is about. So from the internet, there is an incoming connection from a user, and that connection goes to a Kubernetes resource, which is called an ingress. We call it web ingress because it basically serving to the web, right? I didn't include the ingress in the previous list of definition, but it is basically something that allows you to receive traffic from the outside world. Then from the ingress, we send the traffic to the web service, which is the Kubernetes resource that is going to take that traffic and send it to the pods. So it takes the traffic and it sends the traffic to or the request to the web pods. We have a bunch of web pods all together in what we call the web deployment. So the web deployment is composed by pods that they are running engines and Unicorn. They are also running another pod which is not included here, which is the sidecar log collector, which is a container that basically, or a process that basically takes the logs and sends them to a logging service. So what does our application need to run? Well, it needs a database. So we have a DB pod and we have a DB service. We are using Postgres. It also needs Redis because we use that for non-persistent storage. So we have the Redis service and the Redis pod. And it also needs memcache for catching all the views because you know that Ruby on Rails is pretty slow. So we need that. Then we have another deployment, which is the worker deployment. So the worker deployment is using the same image that the web deployment, the same container image, which contains a Ruby on Rails application, but instead of running Unicorn and engines, it's running the rescue process, which is a Ruby library for running background jobs. And again, we can have many instances of these pods. And finally, we have another kind of deployment, which is the cron deployment, which only has one pod, and it just runs the cron tab. We only have one because normally you don't want to run the cron jobs in many times at the same time. So now let's move to Helm, again, very quickly. What is Helm? So Helm is a package manager for Kubernetes. I have to say to the Helm guys, if you watch this on YouTube, hi. When I saw the definition of a package manager, I didn't actually get what it was about. Maybe it was because what we are using Helm for maybe is not the original goal of it. Anyway, it's a package manager. Helm has the concept of shards. So shards are packets of pre-configured Kubernetes resources. You can either use public shards to install apps like Postgres, WordPress, any kind of application. There are a few public repositories, so you just install them with just one command. If you want WordPress on your cluster, you just do helm install and the name of the application, and it will install it for you. Or you can create your private shard for your application. That's what we are doing. We are creating a shard that defines the whole architecture of Gudog. So how do you define shards? Well, you use templates. Templates are just basically the YAML files that you are used to write for Kubernetes, but with templating capabilities. That means that you can do variable replacement and a lot of things that are super useful, as we will see later, if you want to have different environments for your application. So for instance, in our case, we have the staging environment and we have the production environment. And Helm has two different parts. One is the Helm command, which is just the command line interpreter, the client, and then Tiller. Tiller is the server part. It's just a pod that will run in your cluster as a different. It will run in your cluster in the Cueva system namespace. To install Tiller in your Kubernetes cluster, you just install Helm, and then you do Helm init, and that will create the pod for you, and then you are ready to use Helm. Again, if you want to know more about Helm, take a look to this video from two of the maintainers of Helm. There you have the video and also the link to the slides. So how we use Helm? How many of you have or are familiar with our Rails project? Ruby on Rails project. So for some of you, this structure is familiar. This is the typical tree of a Ruby on Rails application. The only difference that we have here with a typical Rails application is that we have a deploy folder and a worker YAML file. If we open the deploy folder, this is what we have. So we have a chart YAML file, which is the definition of our chart for Gudog chart, and then we have all the templates. We also have a bunch of files with values that we want them to be different from our production environment and in our staging environment. And we also have a couple of files that we need to configure engines and Unicorn. So let's take a look to this quickly. Así. ¿No? Bueno. Okay, so here we have the templates folder. In Kubernetes, there is a best practice that some people we follow, which is instead of creating a YAML file for each resource, you group the resources by its main task. So instead of having a web deployment file, web pod file, and so on, we have only a web YAML file. And the web YAML file, sí, ok, estilo americano. Can you see something? Yeah. Okay, so this web YAML file has different resources. Each resource is delimited by this is how you split things on YAML files, right? So the first thing we have is a Kubernetes service, which is gonna select all the pods with the label web, and it's gonna expose them on the port number 80. We also have the ingress I was talking about. So the ingress basically is going to talk to the Google Cloud, and it's going to create a HTTPS load balancer on Google Cloud, and it will link that to Kubernetes. One of the things I was struggling with is that I want the IPs of my load balancer to be static. if possible, because if you start moving IPs, the things get tricky with the DNS. So I want them to be static, but I have a different IP for production and a different one for staging, right? So if you just use the default YAML files with Kubernetes, you cannot do this kind of if thing or templating thing. So thanks to Helm here, I can tell Helm to replace this thing with the proper IP for the staging environment and for the production environment. After the service, we have the deployment. So the deployment, as you remember, it just defines the containers and the number of replicas. Another thing that we wanted to do is we want to have a nice cluster or a nice machine for the production environment, but a small one for staging, because we don't want to spend a lot of money on staging, right? So we cannot afford having a lot of replicas on staging because we will run out of RAM memory. So the number of replicas, again, here is another value that you can replace. And finally, here is the definition of the pods. This is a bit ugly. I think they are going to fix this thing. It's just basically taking another file, the Railsame file, and pasting it there, and then indenting it 10 times, because if you just do this, it doesn't work. Anyway, and here is taking the image or image in the version that we want to deploy. And finally, we have the volume definitions. We have a couple, here it is. Yeah. We have a couple of volumes, one for the logs of engines and one for the logs of Rails. All the other static files like image and everything, they are stored into Amazon S3. So we don't need a persistent volume for that. Here is the restart policy. This is similar to the thing I was telling you about how to deploy, how to tell Kubernetes how it should deploy a new version, and so on. We have also, this is the web one, this is the worker one, which is pretty much the same, but the difference is that the worker one, it's running a different command, which is here. So the worker one is taking the same image, as you can see here, image values with image, but instead of running engines at Unicore, it's gonna run rake rescue work, which is the command to start our workers. This is just the database. So again, it has service, it has a deployment. Why do we have a deployment and not just a pod? Well, because if the pod goes down, if you only have the pod and you don't have a deployment resource, Kubernetes won't start it again. So the way to make sure that you have at least one pod running or X pods running is by using a deployment. There are other ways, but this is the simplest way. And that's pretty much it. There is also the main chart file, which it doesn't have anything. And here are the values for staging and the values for production. So here is where we tell how many replicas we want of the web deployment on production, how many of the worker. You can also define different limits for each container, and they can be different between staging and production because you don't have the same amount of CPU and memory. And that's it. Let's move on. Any questions so far? Yeah.
I saw in a previous I saw on a previous slide the diagram saying what you have, your replicas, pods, and stuff. And there I see only one replica of DB, of the Postgres and the Redis and stuff. You only have one replica.
Yeah, because again, we are Docker scale, not unicorn scale yet. One of the reasons we have that is that Google Cloud still doesn't offer a managed Postgres SQL service. It does offer a managed service for MySQL, but not for Postgres. So if you want to have a master replica set up with Postgres, you have to do it yourself, and I didn't have the time for it. When we were using Amazon Ops Work, Amazon offers Amazon RDS, Amazon Relational Database Service, and you can just create a replica with one click, which was super convenient. So ideally, we need to have more pods or slaves. It wouldn't be the same kind of pod because it needs to be a slave, not a master node. But yeah, we will have one right now.
Yeah, I have a point of your YAML problem. If you put quotes inside quotes, the brackets, it reacts as a string. So you don't have the problem. The problem is the open bracket is a YAML symbol for a dictionary, and you are trying to define a string.
You mean in the files.get thing?
Yeah, your problem with YAML, the open brackets,
But you mean here?
Yeah, if you use quotes, you don't have to indent and put on the.
This thing?
Yeah.
Well, yeah, maybe. I'm not an expert in YAML. I tried many things. This work, and I didn't spend more time.
Quotes work.
Yeah. Okay. I will give it a try. Thanks. By the way, this templating system is based in Golang. There is a template system because the Helm tool is written in Golang. So I'm not still very familiar with it. So I just hack myself to make it work. Okay. Thanks. Okay, any other question?
One more. I noticed in your YAML files you're making your own.
Sorry, I can't hear.
Sorry, you're making your own charts for Redis and Memcache rather than using the publicly available ones.
Sorry?
You're using your own YAML files for Redis and Memcache. And using the public.
No, I'm using the public image. I can show you here. No, this one. This one. So here, this is the Redis deployment. Here you see that the image is just Redis. That's the official image.
But why don't you use the Helm chart as a dependency rather than creating your own?
I could do that, but for me it's simpler to have a single chart that is defining the whole infrastructure. Because the point of this is that this folder with all the templates is part of our main repo. So if we just want to upgrade something or change something on Redis or application, we just make the change to the YAML file. We push it to Git. And Wercker, as you will see later, it will do the rest by using Helm upgrade, which we will see next. Thanks. Okay. Another one? Okay.
How do you handle the database schema changes?
That's something I still have to figure out. I know how, but I didn't have the time to do it. There is a Kubernetes resource which is called jobs or something like that, which is something that you can run just one. So you basically, the idea is you create a new pod with or Ruby on Rails image, but instead of running the engines command, we run the rake-db migrate command, which is how you do migration on Rails, and Kubernetes will make sure that that gets executed once, it dies without errors, and that's it. So that's how I know I should do it, but we don't modify, after 4 years, we don't modify our database that often. But that's a very good question. Okay, so we were here. Okay, so we took a look to Helm. So last thing is take a look to Wercker. So Wercker, I don't really know how to pronounce Wercker neither, sorry. It's a Docker native continuous integration and continuous delivery platform which is specialized in Kubernetes and microservice deployments. The main ideas behind Wercker is that you define your whole CI/CD process as what they call a workflow. And a workflow is composed by multiple pipelines. And each pipeline is defined by multiple steps. So, and also Wercker offers a registry of common steps that we will see later. For instance, to install the Kubernetes command line. How do we use Wercker? So this is the Wercker, a code for Gudog. Here we have only one workflow, and our workflow has 3 steps: the build step, the build container step, and the deploy staging step. Something that I have to mention is that so far we only do continuous delivery to staging. For production, we just go to worker and we click one button. This is just a security measure. But if we want to automate deploying to production, it would be as simple as creating a new workflow like this, but instead of deploy staging, we will have deploy production. So this workflow, if we take an interview, it looks like this. So the first step is the build step. One of the ideas of worker is that each step is independent from each other, right? You can generate some artifacts and pass the artifacts to the next step, but the idea is that you start from scratch. So on the first step, which is the build step, this is where we run the test. So first thing we do is we install Node.js. We install Phantom.js because we need that to run our automated test. Then we install our Ruby dependencies by using bundle install. We create a testing database using regdb create. We finally run our tests with the rspec command. And finally, we send a notification to HipChat with the result of the build. After that, if everything goes well, we move into the next pipeline, which is the build container. So the build container is going to start again from scratch. So we have to install again our dependencies. But the good thing is that the dependencies that you have on the testing environment usually are not the same that you have on your staging or production environment, right? So for instance, on staging and production, we need to have engines and well, also Node.js, but we don't need Phantom.js, right? So we do that. Then we also copy the engines and Unicode configuration files to the proper path. We run bundle install, but this one is not exactly the same one that this, because this is going to install the testing dependencies for Ruby, and this is going to install the production dependencies for Ruby. And finally, we take the result. So this is running all in a container in Wercker, and then we do Docker push. This Docker push is, as we will see later, is a special step that Wercker offers you, which basically takes the running container, the status of the running container, and it will push it to the registry. The idea is similar to a Docker file, but it's not the same thing. And we will talk about why we are not using Docker files later. And finally, if this goes well and we have the image on, by the way, CGR is Google Container Registry. It's just a service from Google Cloud that allows you to upload Docker image. If this goes well, we move to the deployment pipeline, where first thing we do is we install the Kubernetes command line, we install the Helm command line, and then we run Helm upgrade. This is what is going to take our chart, which is on the repo. By the way, all these 3 steps, the first thing they do is that they download the repo, okay? So it takes the templates and it just runs the upgrade with the new version of the image. And this is gonna make Kubernetes to do the deployment with the strategy that we have defined. So in our case, the strategy that we have is that if we have three pods, running our Ruby on Rails application and we want to deploy a new one, we just kill 2, so we keep one running, then we start 2 more, and then when they are ready, we kill the old one. So there is always one pod running, so we don't have any downtime. And finally, we have a HipChat notification, because we haven't moved to Slack yet. So I was mentioning why we don't use Docker files. Well, when I was trying to move Gudog into Docker, one of the problems I was struggling with is that how I should handle this problem of having different dependencies on testing and production. because it's not just operative system dependencies, it's also Ruby dependencies. You don't want the same thing in your testing container than in your production container. So either you create a mega container that includes everything, or you create a base container that includes like the minimum, and then from that you create a different container, but it's kind of annoying. And then I found that the guys from Wercker, they wrote this blog post, which is Docker files considered harmful, and they basically tell you, do not write Docker files. Instead of use or service, which makes sense, but despite of the marketing intent of, or the maybe marketing intent of this post, for me the approach that they are suggesting, it works pretty well. So let's take a look to our Wercker file. Okay, so this is the Wercker file. So first we tell Wercker which Docker image we want to start from. So we start from the official Ruby image on version 2.2, and then we have the 3 steps of our pipeline. First step, again, as I was explaining, is the build step. For running the build step, as we don't want to spin up a new container with Redis and Postgres, we just tell Wercker to provide that for us. So we tell Wercker which service do we want. We say we want Redis and we want Postgres. And Wercker is going to spine 2 containers, one for Redis, one for Postgres, and it will connect them to our container, which is going to run our test. We install the dependencies, as I was explaining. This thing here, this is a started step from the Wercker repository. So if I want to install Phantom.js and there is no easy way to install the version I want, I can go to the Wercker registry and look for someone who already did this work for me, and I just put the name of the step there, and it works. It's kind of the same idea that the guys from Helm, they have with the charts, you know, like trying to, or the same idea that the guys from Docker have when they offer a public image for main services. Then we create a database, we run RSpec. There are some other things that I didn't include in the previous diagram, but that's it. And then the heap check notification. Pretty simple. If we take a look to the next step, so the next step again starts from scratch. So it's going to install the dependencies. In this case, install engines, also the cron, and so on. It copies the file from, this is the path in our repo. It copies it to a different path, and the engines file, which is in our repo, it copies this file to the etc engines.conf, which is the default path for engines configuration files. Then it runs bundle install. Notice that here we are doing bundle install without development and test, to not install the Ruby dependencies for development and test. And then it also does the asset precompilation, which we are not doing in the previous step, and so on. And finally, we run this step. This step again comes from the Wercker registry. You can notice that all these steps are a script or some command, and this is just a name. And this is going to take the status of the container up to here, and it's going to push it to the Google Container Registry by using these variables, which you can define from the Wercker UI. And finally, the deploy, it just installs the Kubernetes command line by using another step by this guy named Riseo. It also installs Helm. And finally, here is where the magic happens. This is the command that is going to perform the actual deployment, which is Helm upgrade. So we tell Helm, which is the name of our chart, which is Gudog, what is the path for our templates, and which are the values that we want to replace. So the first thing that we do here is tell Helm, take the values file for the environment we are running, right? So if we are running staging, this is going to be staging dash values. And then finally, we pass the image that we want to deploy. So when you create a new, when you run your workflow, Wercker defines this environment variable, which is where git commit, and this is what we use as a tag for our Docker image. and that's it. It just finally it runs the heap side notification. And I think that was pretty much it. Yeah, thank you.
Hola. Entiendo que el flow que has enseñado antes, I understand the flow that you showed before is the deployment flow, like CI and CD. I'm curious about your development flow, like just continuous integration, people creating topic brands, pushing to GitHub, I guess, or somewhere. How do you do CI? How do you run tests?
The first answer is that, again, we are not at a big scale. So when Alex told me about giving a talk here, the first thing I thought is like, much scalability talk, we are not scaling that much. So we don't have those problems that other teams, like probably your Talent team, or those challenges, not problems, they are facing, as you are mentioning. But how do we do development? Well, we don't use Docker for development. We tried to. The experience was pretty bad. The Docker for Mac that is available so far, in my opinion, is not good enough. It has a lot of problems. It creates this huge file that it keeps getting bigger. There is this issue on the Docker repo, which is open for a long time. I don't like the experience. I like the experience for deployment, but not for development. And as all the Ruby on Rails ecosystem plays very well with Mac machine, and that's what we are using, we don't have that problem. So we run our tests natively in macOS, and that's it.
And then I have a question about Wercker, because maybe your answer is we are not on big scale, so maybe you can answer. But about continuous deployment or integration services, I'm always a bit skeptical about pricing, because as soon as you need many concurrent builds, it gets very, very expensive. Like, what do you think about the pricing of Wercker, and what's your concurrent builds?
We are still on the free plan. So I can't tell. I'm sorry, I can't really tell. You can always try to do the same thing. I mean, the first thing I tried when I wanted to have continuous integration was to set up my own Jenkins. And then Civil came, and it was the first, or at least the first I knew, continuous integration server that had a free plan for private repos, because all the other ones, they were like Travis, CircuitCI, they were free only for public repos. We don't have that many commits or that many branches every day that we need to run. Well, actually, not in Wercker, but in CPBall, we were using CPBall in my other company in Diacode, where we were doing consultancy, and there we were working different projects, and sometimes we had to wait a little bit because you only get one process on the free plan, even if you have different repos. But I don't know, like our test suite takes like 4 minutes. I don't mind waiting 2 more, as long as it works, as long as it's not half an hour.
Thank you.
Hi. Do you have any strategy to take in account the gap when the English controller have when you do the deploy? Because when you do the deploy, you can have the pod readiness proof already done, but the English controller maybe is not already updated, no? You know?
Yeah, I had that problem. I had that problem that the pod was ready according to Kubernetes, but it was still not ready. So the web service was reporting that it was dead, and then everything goes crazy, and it takes like 10 minutes to actually to let it fix it by themselves. It was annoying. So the way I solved this thing, is the other file, sorry. So here it is. So what I do, this is the web deployment definition. What I do is that I define a reading is proof for our web pod, which basically is gonna do a request to this path, and it has a period of 30 seconds. So the first one is gonna fail, but normally after some, it works. I mean, I play with these values but this is the idea. Basically, you have to tune the readiness proof. Something I learned with Kubernetes is that you have to do a lot of work. Like, it's amazing because you have a lot of control, it's super powerful, but you have to do a lot of work. I also have another problem where Kubernetes was killing my pods. And that was because I was not defining the resources properly. So we had the worker pods, we had a rake task that was being executed time to time, and we were doing crazy things like users puntual, those things that you do in Ruby when you don't know, and it was eating the whole memory, and it was killing, it was a total chaos. So the way we solve this now is by defining resources for every pod. So here I'm telling Kubernetes to limit the amount of CPU. This is not megabytes, this is just a unit that they use, and this is megabytes for each pod.
Thank you. Another question, did you try some other ingress controller, because GLBC is very specific for Google Cloud, and it have some constraints, like it doesn't support, for example, WebSockets, and you need an IP resource for every ingress resource.
No.
And it have.
No, the answer is no. I'm sorry. Actually, the ingress resource is still beta, as you can see here. So this is quite new. So it's getting better. Again, I was having this problem where I couldn't have an ingress with SSL and getting the actual IP of the user. The ingress was sending me, or the load balancer, which is behind ingress, was sending me the IP of the load balancer itself, which was totally. And the guy from Google was like, well, it's not a big deal. It was like, if a user sign up, I want to record which IP he signed up from, right? It's getting better, but it's still beta.
Okay, thank you.